Hello everyone. In this video we're going to be talking about en-route control. As we already know, air traffic controllers provide information, alert and control services, and in this case they do it in en-route volumes of airspace, flying information regions, upper information regions. Considering established flights, that is flights at a constant flight level, and typically constant speed, but also traffic in evolution, traffic that is climbing or descending to the requested flight level or to a given step climb they want to do during the cruise. Now, in route controllers, they do work in area control centers, ACCs, in Madrid, for instance, Torrejón, and they execute their duties on a volume of responsibility called sector, right? ATC sector. So, for instance, here more or less Spain, right? Which is divided. This is more or less ACC Madrid, and this is divided into a number of roughly 10, 12, 9, 10, 12 sectors, right? Lower and upper space for the en route. Okay, and in this each of these guys, we are not going to go into the detail of the name and even the perimeter or the coordinates. If we zoom on one of these guys, we have here two controllers working. One is the so-called executive, and the other one is the planner. Here we will have something called collateral sectors, one to the right, another to the left, and the executive is the one actually monitoring the evolution. Well, both of them are monitoring the evolution of traffic, but is the one to instruct any order, any clearance, to establish communication with all the flights, right, crisscrossing the sector at that time. What is the planner doing? The planner is mainly organizing the transfers between the collateral sectors. So who is coming in, because the executive controller doesn't know, right? And when someone is going out, it has to be transferred also to the planner controller of the collateral sector. Plus, eventually helping the executive in whatever situation, right? That of course. Now, when it comes to crossings, right? The executive controller is monitoring the volume of traffic, and we might have crossings, right? And we have three possible configurations. This one, the first one, is same track, right? You can say this is the same track. When we have this plus minus 45 degrees between bearing between the tail and the head of each two aircraft. They are going in the same direction, right? That's 45 degrees. The other configuration is the so-called reciprocal configuration, and this is the other way around. We have 135 and 135. Or in other words, 135 and 225. If the aircraft is between 135 and 225, then we would say that is reciprocal. They are kind of head to head. And the third one is just crossing, right? Crossing more or less in a more or less perpendicular configuration. And the way of solving these conflicts might be different when they are in the same track. It's easy because you can just play around with the speed. When they are in a reciprocal situation, it's good to provide the same advisory in the same direction to both of them, right? To avoid any, because if you're here and just you vector one to the right and the other one to the left, you are regenerating the conflict. Plus, if you vector one to the right and the other is not touched, you still don't know whether this is gonna work. And in the crossing, yes, you would try to. Uh, the idea would be to put this one at the tail. Okay, always when you solve a conflict, you try to um, get one through the tail or the other. Right, in here you would try to do something like this, right? By also vectoring this one, and in the same track they are already one at the tail or the other, so you don't need to actually vector. So that's pretty much the idea. And now let's check what are the some tools that controllers have to kind of monitor the traffic and advise. So the first one is the so-called tactical controller tool. I mean, this might vary. I mean, we have only in Europe 20 something air navigation service providers, each of them with different tools, even with the same provider, Indra, but with different versions. So this is the Spanish one, and in the Spanish one we get something like this in here. I don't know if you can see it. We can use the red, right? It's a tool that is a human decision support tool, right? And this here we're coming into automation. To which extent a controller should be alone, thinking and executing as a human being, with pros and cons. To which extent machine should not only provide information but eventually recommend or even implement a decision, uh, or eventually substituting the human being, right? So that's the point. So at this level, we have just information. This is not even suggesting a solution or suggesting a set of solutions, which could be the case. But here we have information on the varying. So what is the angle between these two? This here, right? 289. Then what is the actual distance? 10 nautical miles. So it's providing information about the configuration of the crossing. Mm-hmm. It's providing information about the current distance, and it's also telling that in 2 minutes, in 2 minutes time, you're gonna have the minimum separation, which is 5.1. 5.1 is already telling you that it's gonna be a conflict, right? Because so something needs to be done, and this is what controllers use as a tool to actually take decisions and instruct others. They also do their own calculations, and that's the way they work. Besides that, there are other tools like short-term conflict avoidance tool, and another one called the medium-term conflict avoidance tool. This is the medium term. Those are just alerts. Okay, so you would have a pop-up in the screen saying that a potential conflict is to happen. Having alert system is you always need to have a trade-off between the false negatives and the false positives. It's too many or too many false alarms would make the user not to rely on it and probably is disturbing. But a false negative. But so you say there's not gonna be conflict. You rely on that alarm, but at the end, all of a sudden you realize that there is a conflict. This might be dangerous, right? So you need always to put a trade-off there. In any case, the short term one works 2 to 4 minutes before something called closest point of approach, which is like the intersection of the two planes of movement. Right? Take a plane, one aircraft with a vertical plane, another one. If we project them, the intersection would provide you that the time of closest approach. Is said closest approach because they might be flying at different levels or slightly different altitudes, right? So you could not have a intersection of two lines. Now, if we do kind of basic maths, say uh, the aircraft is flying at a ground speed of 420 knots. This, if we know that a knot is equal to 1 nautical mile per hour, we know that this means the aircraft is flying 7 nautical miles per minute. These are the rule of thumb numbers that the controller might be doing, right? Now, when this is popping up 2 minutes, up to 2 minutes before the closest point of approach, it means that in 2 minutes the aircraft is flying roughly 14 nautical miles. So we still have some time, but we are really close to the conflict. The medium term one is for 4 to 20 minutes. This one would be good eventually if the prediction of the characters would be good, the winds and so on and so forth, because otherwise it's not meaningful. But of course, the short term might be two aircraft, so pairwise solution, and the medium term one might take into consideration a scenario with more aircraft, in a way that a controller might take a holistic solution, right? Not just solving one by one. Then what is the domino effect? We don't know, but taking an overview on the situation and choosing the best solution, right, with the information it has. And that's all. Thanks very much for your time.